thought about it, and I really want to spend the rest of my life with Amy. Do I have your blessing?
Well, Sheldon, I think you should make her finger like Saturn and put a ring on it.
You asked Stephen Hawking and not her father?
Stephen Hawking's a genius. If he said no, I wasn't going to waste my time on her father.
That was the acclaimed scientist Stephen Hawking making a cameo on the hit TV show Big Bang Theory. Now, he often said humor helped him cope with ALS, also known as Lou Gehrig's disease. Hawking died peacefully today. According to his family, he was at his home in Cambridge, England. Now, he was famous for his book, A Brief History of Time, and research about black holes and the wonders of space. Now, his work led to the discovery that black holes leak energy and fade into nothing. And he once said, it would not be much of a universe if it wasn't home to the people you love. Now, Hawking is also known for his stern warnings about the fragility of Earth. Saavik Ford is a research associate in the Department of Astrophysics at the American Museum of Natural History. She is also a professor at the CUNY Borough of Manhattan Community College. Welcome, Saavik.
Thank you, Duarte.
Such a sad day, but a wonderful life.
Yeah, Stephen Hawking had an amazing life story, really. When you think about it, he starts out as a student at Cambridge and he's working towards his PhD, and he's interested in many questions about the nature of our universe. And at that moment, when he's close to getting his PhD, he is struck down by this terrible diagnosis, and the doctors at the time gave him just a couple of years to live. And
how old was he at the time?
I've forgotten, but he was very close to finishing his PhD. And so it was just at the point in an academic's life where he is going to be looking for a job. And one of the things that he wrote in his book, A Brief History of Time, was that although he didn't know how long he had to live, he wanted to get married. And in order to get married, he needed to make some money. So he decided that he'd better go out and get himself a job. And so that was sort of what motivated him to keep going in the face of this difficult diagnosis, that he wanted to understand more about the universe, and he just wanted to keep pursuing his life.
It's gotten to the point where Stephen Hawking is one of these iconic intellectuals, dare I say geniuses, that, you know, people really forget or don't quite understand his contribution to science. We understand his contribution to popular culture, so much so that, you know, comic book heroes like Professor Xavier on the X-Men may have been partially inspired by Stephen Hawking's. But if you could explain exactly what his contribution to science was.
So, as you described in your introduction, he is the inventor or the discoverer or the conceiver of Hawking radiation, what we now know call Hawking radiation. And this came from his idea that we could take our understanding of very strong gravity, which comes from Einstein and we call general relativity, this idea that in our universe, if you have a mass, it will bend space and time around it, and it will change how clocks run and how meter sticks measure. And then there's also this other idea that we have called quantum mechanics, which is our understanding of very, very small particles, so subatomic particles like electrons and quarks and protons and neutrons. And there's some not clear interaction between them. Today, we still don't really understand how those two ideas come together in our universe. But Hawking was one of the first people to recognize that quantum mechanics says that you can borrow particles from the universe, from nothing, as long as you do it for a very short period of time. And that comes from Heisenberg's uncertainty principle. And Hawking said, what happens if I do that right at the edge of a black hole, at the event horizon, where there's a point of no return, and I borrow a couple of particles, but one of them goes into the black hole, and one of them goes out. And so now I can't return the particles because they're not near each other anymore. One of them has completely gone away from the black hole, and one of them has gone in, but I borrowed this energy from the universe. So what am I going to do? Somebody has to pay that bill. And Hawking realized that the black hole can pay the bill.
The black hole itself.
The black hole itself. And this is why the black holes evaporate. It's the particles that are escaping. They're popping into and out of existence right here, right now, actually. And we have experiments that we can show that there's particles that are just constantly popping into and out of existence. And as long as they do it really fast, no one will notice and it's just fine. But if you do it right at the edge of a black hole and one goes one way and the other goes the other way, you can't bring them back together to make the books balance, and so somebody has to pay the bill, and the black hole is what pays the bill.
And so, if I could rephrase it, if I'm understanding it correctly, you know, Hawking's genius was that he realized that the black hole pays the bill for that movement.
That's
and before that, it was an unheard of idea that wasn't proved.
That something could get, actually, nobody had thought about what would happen if this sort of thing happened near the edge of a black hole. So he was the first person to say, oh, wait a minute, there's this idea of a black hole where it has this point of no return, but then there's this idea from quantum mechanics that particles are popping into and out of existence. So what if I just put them together and said this happens right at this boundary? Wait a minute. And he was the one who then worked out the math to say, oh, okay, wait, but that means that black holes will evaporate. But wait, I better put a paper out on that.
You know, I look at you and your eyes just light up so much as you talk about him. I imagine he inspired you as well.
Absolutely, absolutely. I remember reading A Brief History of Time when I was a teenager and a young college student, and I found it to be really fascinating playing with these ideas of space and time and energy and matter. And so it was definitely an early inspiration, and I absolutely, anytime, you know, I would get down on myself, I would remember, well, you know, at least I can walk. If
right.
That man can get up and he can go out and pursue his career, maybe I can find a way to keep going.
It's such an inspiring life. In terms of other scientists, are there others in the horizon that you see that are rising to levels of prominence that could one day be on the same level as Hawkins?
I think that, of course, Neil deGrasse Tyson is already an extremely prominent scientist. I think that many of your public probably know about him. Others who have a slightly lower profile, who are perhaps rising, I would include Brian Greene, Janna Levin. All of these people actually are in New York. So I'm a little bit New York biased, but yeah.
One of his great gifts, aside from his superior intellect, was that he was able to make science more understandable. I see you did a little bit of that as you were explaining this complex theory to me, but if you could explain to me how you actually do it, I'd be interested to know.
So I am a professor, so I teach classes, and one of the things that I love to do with my own students is tell stories. So I enjoy telling them the stories of the people who have done the science and why they did it, right? So with Hawking, he wanted to understand why it is that general relativity, our understanding of gravity, and quantum mechanics, our understanding of very small particles, don't quite agree on what you would expect to see in all parts of the universe. And so he was bothered by that and wanted to reconcile them. And so this is the theory of everything that physicists are often pursuing. And that was the name of the biopic, actually, an excellent biopic about him. And he didn't quite get there, but we're still going, and we're still hoping. And everybody has a reason. All of these things that we discover, there's a reason for it, and there's a motivation behind it. And so I like to tell my students the stories of the how and the why, and sometimes to give them the facts and help them to try to construct their own story. And we can construct a story together and sort of rediscover what it is about the universe that people found in the past and how they found it and why it was interesting.
I know we don't have very much time, but you are actually doing some of your own individual research. In 30 seconds, could you tell us the why?
Sure. So I want to understand, just like Hawking, what it is that underlies gravity in our universe. What is this understanding of general relativity? What does it mean? Can we test it? And this contradiction that we know exists between general relativity and quantum mechanics. Some of his later work, more recent work, was actually trying to reconcile these two in other ways that we have not been successful at. And I'm particularly interested in testing general relativity through observations. So gravitational waves are waves that are emitted by masses that are moving in space-time, and as they move, space-time is rippling, and the ripples move out, and they can be detected, and how those ripples actually arrive and are detected will be different depending on which version of gravity you believe. And so I'm quite interested in testing gravity in that way.
Fascinating, Saavik. I really appreciate having you. Quick note, your name actually comes from Star Trek.
Yes, it does.
I love it. Thank you so much for explaining that and helping us honor one of the greatest scientists we've had.